In the following past paper question, you're being asked about Bronsted-Lowry acid-base definitions, and the question states that the theory describes acid and base character, and then you're given when concentrated sulfuric acid and concentrated nitric acid are mixed, the following reactions occur. So the three reactions that are given, so there's a sulfuric acid and nitric acid reaction. It has three different steps. Now the question states which of the species are bases in these reactions. And the first species that we need to discuss is HSO4 minus. The first thing we need to do is that we need to we need to state what an acid is according to Bronsted-Lowry theory, and that is an acid is a proton donor, or it donates an H plus 1 ion. Whereas a base, on the other hand, accepts, so it donates or produces an H plus 1 ion. And on the other hand, a base is something that accepts H plus 1 ions. So it's going to accept H plus 1 ions. Remember, bases are also compounds that have OH ions. These OH ions have the ability of accepting H plus 1 ions. So the first option is HSO4 minus, and we need to decide whether it's a base or whether it's an acid. So we need to figure out where HSO4 minus is appearing. So if you look over here, this, and it's appearing in two places. In the third reaction also there's HSO4 minus ion. So if you look at the first reaction, and if you look at that reaction in the backward direction, this HSO4 minus ion is playing its part in the backward reaction. It changes into H2SO4. So when HSO4 minus 1 changes into H2SO4, what is it doing? It's actually accepting. So it accepts an H plus 1 ion. And bases are substances that are accepting H plus 1 ion. So this first option looks perfectly correct. Which species are bases in these reactions? We can also look at the third reaction as well for HSO4 minus. And if you look at it in the backward direction, you would notice again that it's getting converted into H2SO4, so it's accepting H plus 1 ion. So it's also acting as a base in both reactions. It's acting as a base. Now moving on to the next option, which is nitric acid. The first option is correct; it's a base. Moving on to nitric acid, HNO3. Let's figure out where HNO3 is. So HNO3 is in this first reaction, and if you look at this reaction in the forward direction, HNO3 gets converted into H2NO3 plus. So clearly it's gaining an H plus 1 ion, so it also accepts an H plus ion. So it is acting as a base in the first reaction. HNO3 is acting as a base. There are no other places where HNO3 is appearing. So this HNO3 over here gets converted into H2NO3 plus, which means that it's gaining one H plus 1 ion. And it's acting as a base. So the first two options are correct. And moving to the third option, which is NO2 plus. Let's find out where NO2 plus is. There's only one place where NO2 plus appears, and that place is over here. This is where NO2 plus, and again it's a reversible reaction. So let's look at the reaction in the backward direction. NO2 plus gets converted into H2NO3 plus. Now if you look carefully, NO2 plus is gaining an H2O molecule. Now remember, gaining an H2O molecule does not, it has to be an H plus 1 ion. So NO2 plus is not acting as an acid or a base. It's not gaining or accepting or producing H plus 1 ions. It's not an acid, it's not a base. It's actually gaining an H2O molecule, which is a neutral molecule because it contains both H plus 1 and OH minus 1 ion. So if something gains an H plus 1 ion and an OH ion, so basically that thing is neutral. It's not acting as an acid or a base. So we're going to cut out NO2 plus. So according to the marking key, if the first two are correct, the correct option is going to be B.